Now that we have a better understanding of the general types of visualization in manufacturing, let's explore some of the typical features of an HMI, starting with the most basic features, displays and objects. A well-designed HMI application has an effective hierarchy of displays that guides users through the system. The hierarchy provides them with progressively more detail as they move through different levels of HMI displays for information and data. Click on any of the screen objects to hear more. Click Continue to move on. As for look and feel, busy, cluttered graphic elements common to traditional HMI displays have given way to a much more modern appearance in automation today. Too many animations and colors create distractions for operators, making it difficult to identify alerts and resulting in a loss of productivity. However, colorful displays are still commonly used today in flashier sales demos. With the help of today's standards like ISA 101 and ASM, operators are more likely to be presented with much simpler graphics with grayscale colors. Graphics designed for simplicity and situational awareness ensure abnormal situations can be addressed properly. When an event occurs where operator attention is required, the graphic would highlight that change and drive operator attention to it. Studies suggest that response time to abnormal conditions can be reduced by an estimated 10% with the implementation of a standard user environment designed to ISA 101. Next, let's address alarms. By definition, an alarm is a visual and/or audible signal indicating an occurrence of an abnormal condition that requires an operator action. Alarms are displayed in the HMI on a graphic referred to as an alarm summary display. Within this summary, operators can interact with the alarms to validate and initiate remediation as necessary. ISA 18.2 standards define types and guidelines for alarm interactions, such as acknowledging, suppressing, silencing, and shelving, just to name a few. The ability to store and display live data values throughout a manufacturing process is an essential function of any graphical HMI. Trending is the ability to display and compare values graphically. An HMI trend configured to read and display these values directly from the controller is referred to as a real-time trend. Data logging is the ability to periodically store key values during production for evaluation or validation at a later time. An HMI trend configured to read and display these values from the storage location of a data log file is referred to as a historical trend. Recipes are sets of related data parameters and values used to make a product. Examples of these could be oven temperatures or cook times. They may also include ingredients such as milk, eggs, or sugar, along with necessary quantities or weight measurements. The management of recipes range from storage within the controller for the simple ones to large databases for the more complex. The ability to manage recipes from within an HMI is, however, one of the most common methods. Most HMI-based recipe tools allow users to view, select, modify, activate, and save recipes directly from within a running application. The ability to sell and compete globally is becoming increasingly more important to both machine builders as well as end-user manufacturers. With multi-language support, HMI applications developed in one language can be easily translated into other languages to support localized manufacturing. In addition, many systems allow operators to actively switch between the different languages right within a running application, a feature referred to as runtime language switching.